In this lecture, we will learn about soft and hard links. But before we move on to soft and hard links, you need to know what an inode is. Inode stands for an index node. Each file at the time of creation has many attributes assigned to it, such as file's type, size, permissions, owner's name, group name, access control list, links, and other related info known as metadata. This metadata info takes only 128 bytes of space, and this tiny storage space is known as an inode or an index node. Inode assigns a numeric identifier to each file, which is used by the kernel. So for example, if you look at this example, this is showing you the rights of a file, for example, the name of the file, the permissions assigned to a particular file, who's the user, who's the group, when was the file created. All this information is known as the metadata. This is the metadata of a file. That's how your kernel understands what this file is. The metadata is then saved as an inode. So there's a small tiny storage space. It is known as an inode or an index node. Inode then assigns a numeric identifier to each file which is used by the kernel. You can probably say that a file really is the inode, and names are attached to this inode to make it easier for humans to work with them. So when you look at a file, you'll see like a file name as, for example, file 1. But your kernel understands the file 1 as a numeric identifier number, which is known as an inode. Let's start with what a link is. A link can be compared to a shortcut. It's basically a pointer to another file. In Linux, two different kinds of links are supported, the hard link and the symbolic link, also known as the soft link. Let's start with the soft link. Soft link is also known as the symlink or symbolic link. Soft link is similar to a shortcut in Windows. They point to another file. If the original file is deleted, symlink becomes useless as it is a shortcut to a file that does not exist anymore. Let's look at an example. We will create a soft link to file 1 and we'll name it something, maybe file 2. And then we will do an ls and look at some of the rights, and I'll show you how it looks like, how you can identify a soft link. And we will also create a soft link. We will also look at the inode and how to find an inode of a file. So let me open up the terminal and let's look at these examples through the terminal. So currently I have a file called file 1. Let's create a link to this file. To create a link, we'll type in the command ln. It stands for link. And if we type in a -s, that means a shortcut to file 1. And then the shortcut will be called file 2. Hit enter. Let's do a ll or ls-l you can do. It's the same thing. And look at file 2. Now if you look at file 2, on the right side you will see file 2 and there's an arrow. It means file 2 is actually a link to file 1. And if you look at on the left side where you see the permissions, there's a L before it. That means there's a soft link there. When you create a soft link, do ll or ls-l, you will see a L listed here. When you see that, that means there's a soft link there. And it's showing there's one link right here attached to this file. That link is pointing to file 1. So file 2 is a shortcut to file 1. And that's a soft link. Now, to find the inode of a file, you can run ll with a -i option and name of the file, file 2. Hit enter. Now, all the information is still the same except that it also added another column. And this is the inode number of this file. So that's how you can find an inode number, and that's how you can create a soft link. Now let's look at a hard link. Hard link associates one or more files with a single inode number, unlike a soft link. This also implies that any changes made to original file will also be applied to the hard linked file. For example, to create a hard link to a file, you just type in ln and then the file name and then the name of the shortcut that you're creating or the hard link that you're creating. So let me bring up the terminal and let's look at this example. So let me do an ls first. As you can see, we have a file 1 and we have a soft link to file 1 called file 2. And before we move on, let me show you one more thing. Let's do an ll -i and let's do it to both files. One thing I wanted to show you was when you create a soft link, it gets a completely different inode number than the original file. As you can see right here, that's the file 1's inode number, and here that's the file 2's inode number. When we create a hard link does not get a new inode number. It will be the same inode number as the file 1. So let's look at that example. Let me clear the screen and let's create a hard link first to file 1. To create a hard link, you don't need to type in any options. You just type in ln and then the file name. File is file 1. Now we're creating a hard link to file 1 called file 3. Hit enter and the command executed successfully. Now let's look at ll -i to check the inode number of file 1. Okay, so that's our original file. One thing you will notice here it says 2, so it has 2 links to it. Now let's do an ll on the newly link that we created, which is file 3. So if I hit enter here, as you can see, right here is the inode for file 1 and right here is the inode for file 3. Both of the links are the same. So if one file is deleted, the other file will still exist, unlike a symlink. When you delete a soft link, a shortcut becomes pretty much useless. There is also one more thing that you should understand is whenever possible, you should create a hard link, not a soft link, because hard links are much faster and they reside on the system. However, soft links can be created anywhere. Soft link can point to any computer to a file somewhere else, anywhere in the world. So hard link can only be on the same system. That's why hard links are faster, and whenever possible, you should think of creating the hard links, not the soft links.